can see here that I have a second order differential equation because I have here a function on the a non-zero function on the right hand side. This is a non-homogeneous differential equation. I will work for the complementary solution first. So I will go for the homogeneous differential equation. Okay, let me zoom it for better understanding. Okay, so here is my differential equation. Okay, I will put the right hand side is equal to 0 to work for the complementary solution. I will see that here I have double derivative, so m square, first derivative, so m, and then constant 20, right? I will now solve this characteristic equation, and I have using the quadratic formula. So I have here the imaginary root, the complex root. Okay, I will substitute it here. And during the last lecture, we learned from exercise 4.3, we learned a rule that we can take this same term outside the brackets and then e to the power minus 2ix plus e to the power 2ix, and these constants will be transformed. So we can write it like a1, a new constant, cos 2x, plus b1, a new constant, sine 2x. Okay, this is the complementary solution. Now let us work for the particular solution. Please look at the right hand side of this given differential equation very carefully. We can see here that on the right hand side we have a mix of a polynomial and an exponential function and polynomial product. Now let us quickly look at the table that we had. Here is the table. We know that if I have a polynomial, simple polynomial, I will write a trial solution like this. Okay, for example, in the given question, we have the polynomial 100x squared. So I will go for ax squared plus bx plus c. This is in response to the first term of the right hand side. Now please look at the second term of right hand side. I can see the product of x and ex. Now let us take a look at the table. I have here from the table xex. I can see here that if I have a polynomial times the exponential, I will write the long term for this polynomial and then the exponential. So for xex, I will write ax plus b times ex. Okay. So now let us go back to the polynomial, the product of the polynomial and the exponential. Xex will lead to ax. I have already used the words a, b, c, the constants, the alphabet. So I will go for d and e. Dx plus e brackets and times ex. Okay, so this is the plan. Now let us work on it. So my yp is ax squared plus bx plus c. Okay, and my this is yp1, you can also call it. This is first part plus dxex plus ex. Okay, I have opened the bracket and I have now written it like this: ax squared plus bx plus c dxex plus ex. Okay, now this is yp. I will go for its first derivative. Now the next step is to find yp's first derivative, then yp's second derivative, then substitute it in 1. Where is my equation 1? Let me show you. Here is equation number 1. I will substitute this thing yp prime, yp double prime into 1, and I will solve for its coefficients and I will get the solution. Okay, let me leave the remaining part of the solution with you. Please solve exam question number 6 and upload it on portal. Okay, now let us solve question number 7. For question number 7, you can see that in this question we have right, look, at this question carefully, you have y double dash plus 3y is equal to minus 48x square e to the power 3x. Okay, we will work for the complementary solution. So m square plus 3. So the two roots are plus minus root 3i. Okay, so c1 e to the power minus root 3ix plus c2 e to the power root 3 ix. Okay, so you will go for a1 cos root 3x plus a2 sine root 3x. Okay, this is yc, straightforward. Now, always check carefully that there is no repetition. By this, I mean to say that in yc, you haven't got a term similar to the function here on the right hand side, minus 48x square e to the power 3x. Okay, now I have a polynomial, so I will go for ax square plus bx plus c times e to the power 3x. Okay, you can see here that I have here yp as ax square bx c, and outside brackets I had e to the power 3x. Then I expanded the brackets and I have got something like this. The first derivative yp prime, okay, and then I have differentiated it another time. So I have yp prime, yp double prime, and I have substituted these values into the given differential equation. Then I have compared the terms for the coefficients. I have got a, b, c. So y is equal to yc plus yp. And I have got the final solution. Okay, the book by Zill is very nice, and we can learn how to compare the coefficients very easily from the book. Okay, so let me quickly show you an example here. For example, here yp is ax square in example number 1, ax square plus bx plus cy, because you can see here I have a polynomial on the right hand side. Okay, and yc is not similar to the polynomial on the right hand side. So what is the procedure? Yp prime, yp double prime, substituted in equation number 1, the given differential equation. And after the substitution, compare the like terms. Okay, this example is extremely helpful to understand the strategy. You can see here that x square coefficient is minus 2a, and on the right hand side x square coefficient is 2. So compare these two terms. Minus 2a is equal to 2. Similarly, 8a minus 2b and minus 3. Similarly, 2a plus 4b minus 2c and 6. And solve the three equations to find the three unknowns, a, b, c, and you will be able to get yp. Okay, so that is how we work for the particular solution. Now, a very, very important example, example number 4, glitch in the method. Why is there any glitch? Why? Because when we talk about the repetition, we have got to be very, very careful. Okay, for example, here you can see the complementary solution here, y double dash minus 5y dash plus 4y. You will get m square minus 5m plus 4. Put it equal to 0, find the two roots. Okay, so you will get y. Let me quickly take a look at yc. I have my yc here, c1 ex plus c2 e4x. This is the complementary solution. But students, please carefully look at the right hand side of the given differential equation. 8ex here for yp, the function from which we will take the motivation is also 8ex, which is similar to the complementary solution. What was the complementary solution? When we obtained the two roots, we got 1 and 4 as the two roots of the characteristic equation. So I have yc as c1 ex plus c2 e4x, and something similar is already available on the other side, 8ex. So now actually according to the rule was that if I have a exponential function, I will say yp is a, e, and that constant x, right? E5x, then A E5x. So from the given table, according to the given table, if I have 8EX, the particular solution must be AEX. No, it will not be. Why? Because from the complementary solution, I have already obtained EX. So I will go to another term. I will go for another term. Okay. And the rule is that multiply X to avoid the repetition. I repeat, the rule is that multiply with X to avoid repetition. So now this time you will have the YP is equal to AXEX. Why? Because you have already obtained in YC a constant times EX. So to avoid the repetition, you will go for the AXEX. Okay. And we will, in the third video, we will go through some more solved examples where you will see the repetition, and to avoid the repetition, we will multiply with X. Okay. This is a very, very important concept. All right. And I suggest that please go through the example number 5. Okay. I will upload on C online some homework, and please solve the homework and submit it. Okay. And then I will share with you the third part of this lecture. Thank you so much.